So far, when we look at a balanced reaction, so we have all of our coefficients in front, and we have equal numbers of each element on each side of the arrow, we look at this in terms of particles. So in the balanced reaction of two magnesiums reacting with one oxygen producing two magnesium oxides, we view this as two particles and one particle to make two new particles. However, we can look at that a little bit differently. We can also look at that as 2 moles of that particular substance reacting with 1 mole to produce 2 moles. So 2 moles of magnesium reacting with 1 mole of oxygen gas to produce 2 moles of magnesium oxide. Our coefficients tell you both the number of particles or the number of moles. It can be used for either of them. We are going to focus on the coefficients telling us the number of moles involved in a reaction. So here's our first example. Suppose you react 2.5 moles of copper 2 chloride with excess iron to produce iron 2 chloride and copper. How many moles of copper do you produce? We're going to use our balanced chemical reaction to be able to predict amounts of products. So the first thing that we need to do, our step 1, is to write and balance the chemical reaction, or balance the reaction equation. So copper 2 chloride is CuCl2. Iron is Fe to produce iron 2 chloride. So there's our iron 2 chloride, that's the formula for that, and copper. If we balance it, they're all 1s in front. So we have 1 copper, 2 chlorines, 2 chlorines, 1 iron, 1 iron. So now we have our balanced chemical reaction. Our next step is to set up what we're calling a BCA table. BCA stands for before, change, and after. So we're going to look at what we initially start with, what changes happen during the reaction, and what we have at the end of our reaction. So we said that we started with 2.5 moles of copper 2 chloride. We have excess iron. That simply means that we have more than we need to do the reaction. So we know we're going to have iron left over. And we initially have 0 of either of our products. Because when you have a chemical reaction, remember, these exist at different times. You have your reactants and then you have your products. So we start with 0s on our product side. We're going to assume that we use up all of our copper 2 chloride. So we're going to use up or subtract 2.5 moles of copper 2 chloride. And now we need to figure out what we have for each of our other things. If we look at these, they all have a 1-to-1 ratio. There's 1 copper 2 chloride to every 1 iron, 1 copper 2 chloride to every 1 iron 2 chloride. Those come from the coefficients. That means we're going to lose or gain the same amount. So if we lose 2.5 moles, we're going to lose 2.5 moles of our other reactant. And we're going to gain, because we're making our products, 2.5 moles of each of these guys. Our after is simply doing the math. 2.5 minus 2.5 gives you 0. We've used up all of our copper 2 chloride. Excess minus 2.5, we're still going to have something left over, so we still have excess. 0 plus 2.5 is 2.5. And 0 plus 2.5 is 2.5. Our last step, now that we filled out our BCA table, our last step is to answer our question. Our question asked us, how many moles of copper do you produce? So we need to find what we're looking for. There's our copper and our after, so we have 2.5 moles. That's the answer to our question.
So we need to talk really quickly about what units go in the BCA table. You may have noticed that we were comparing mole ratios. So the units that go in the BCA table are moles. We compare moles in the BCA table. So what did we use to connect from the copper 2 chloride to copper? And we used the mole ratio. in this case, we use the coefficient in front of copper 2 chloride and the coefficient in front of copper. They were both 1. So we had a 1-to-1 ratio. So what do we do if the ratio isn't 1-to-1? That's sometimes the case. If the ratio isn't 1-to-1, we decide if the value should go up or down. And we have an example that'll show us how we're going to do that next. Okay, so our example here is suppose you react 4 moles of zinc with excess hydrochloric acid. How many moles of each product will you create? So think back to what step 1 was. Let's pause really quickly and do step 1. So you might remember that step 1 was to write and balance the equation. So what is our equation? This goes back to naming. We have zinc, so we write in our symbol for zinc. Zinc plus hydrochloric acid. Oftentimes we give you this one just because there's no naming scheme for this one that you know of yet, but you've also used it quite a bit too, so you might just remember it. And then you make zinc chloride. And what else did it say we made? Oh, we just remember from before that we made also hydrogen gas. So that is our first step. We have to balance this next because it says write and balance. So we have 1 zinc on this side, 1 on this side. We're good there. We have 1 hydrogen and we have 2 hydrogens. So in order to have 2 hydrogens on this side, we have to change the coefficients. So we change the coefficient there to have 2 hydrogens. Now we have 2 chlorides, and we have 2 chlorides on this side. So now our equation is balanced. You know that if there's nothing in front of it, it just means that there is a 1 there. Step 2. Step 2 is where we're going to compare the number of moles that we have. We're going to put them into our BCA table. So remember that B stands for before. So we'll have to look back at our problem. It says, how many moles of each product will you create if you have 4 moles of zinc and excess hydrochloric acid? So in our before row, we're going to put 4 moles of zinc. And then we know we have excess hydrochloric acid. How much zinc chloride do we start with? We know it's a product, so we have none. We start with 0 moles of zinc chloride and 0 moles of hydrogen gas. All right, so then we have our change. How does this change? So, we know that we use all of our zinc. So we are going to subtract 4 moles. All right, here's where it gets a little bit tricky. We have 2-to-1 ratio for hydrochloric acid and zinc. So now we have to decide, what are we going to do? Are we going to have a 1-to-2 ratio, and we're going to use this number, or are we going to have a 2-to-1 ratio? This is where we have to ask ourselves, is our number supposed to go up or down? So for every 1 mole of zinc, we have 2 moles of hydrochloric acid. So would we expect to have more hydrochloric acid or more zinc? You can see if we have 1 mole of zinc here and 2 moles of hydrochloric acid, we're going to expect to have more hydrochloric acid because in our mole ratio, we have more hydrochloric acid. So then we have to decide, do we multiply by 1/2, 1/2 ratio, or do we multiply by the 2/1 ratio? Which one is going to get our number to increase? So let's try it. We have 4. we're going to multiply it by our 1 to 2 ratio, and we get 2. Did that number go up or go down? It went down. So we'll try the other one. 4, multiply it by our 2 to 1 ratio, and we get 8. All right, so that tells us that we need to multiply it by our 2 to 1 ratio because we're looking for a number that's larger than our 4. So we use 8 moles of hydrochloric acid. Then we go over here and we say it's a 1 to 1 ratio. So we know that we gain, why are we gaining? Because it's a product, 4 moles of zinc chloride, and we gain 4 moles of hydrogen gas. We know it's 4 because it's a 1 to 1 ratio. That makes it a lot easier when it's 1 to 1. We don't have to worry about deciding whether the number's supposed to go up or down. Okay, so now we need to figure out what we have after. After, here, we have 0 moles, which is what we expected, of zinc. We used all of our zinc. And here, we still have excess because we already knew that we weren't going to use it all, hydrochloric acid. So you can just write excess. Over here, we have 4 moles. You don't have to put the plus sign. You have 4 moles of zinc chloride, and you have 4 moles of hydrogen gas. All right, so now we need to figure out what is the question asking. That is step 3. We have to answer the actual question. The BCA table does not answer the question for us. It gives us the information we need to answer the question, but then we have to go back and say, what was the question? So the question was, how many moles of each product do you create? So now we're going to have 2 answers. Our 2 answers are 4 moles of zinc chloride and 4 moles of hydrogen gas. And that's how you would write your answer. All right. Lastly, we need to talk about what key words we can use to help us decide how to solve problems. So when you are losing or subtracting or using up, you are talking about your reactants. You're talking about the left side of your equation. So that's going to be very important when you're reading the problems. You're going to want to pay really close attention to these words that are being used, and you're also going to want to pay attention to what you're doing on the BCA table. You need to know that you are going to be subtracting on that side for the BCA table because you are using up those reactants. For the product side, you're going to gain, or you're going to mathematically add or create products, and that's what's on your right side. So you need to make sure you keep those straight so that way you can be aware of what you're doing to your reactants and your products. All right, so we have a couple practice problems. Make sure you ask a lot of questions because this stuff is a little bit tricky.